Hello students, this is a Python lab where we are going to learn how to build a decision tree, a simple decision tree. Build it and train it on a data set. For the data set, we are going to use empty cars. This data set which I've been using for a lot of my examples so far. If you remember, there's about 32 rows in it, and several columns. So the data columns are starting from the second column, MPG, cylinders, displacement, and so on. And the first column in the CSV file itself in the data set is an index. So the name of the car and several characteristics of this car. So it's a very nice data set. Small and easy to navigate, and that's how I chose it. I set a task of creating a tree which would allow us to predict the number of cylinders in the car by looking at every other characteristics, of course, other than the model and make of the car. Right, so we will be using other columns such as MPG, which is miles per gallon, displacement, horsepowers, and so on. Displacement is a characteristic of an engine. It tells you how big is an engine, and MPG is efficiency of the car, how many miles you can run per gallon, and so on. Actually, if you know a little bit about cars, you would probably guess that displacement is going to be or should be a very good predictor for number of cylinders, right? So bigger is the car, likely the number of cylinders is going to be larger. Of course, displacement per cylinder can also change, but generally, like if you have a very big engine, by displacement, probably it has a lot of cylinders, right? So we expect that maybe displacement will be a good factor here. When you're working with in sort of with real data sets, you don't always have a very good idea of which features should matter, of course. But it's case by case. Sometimes maybe there's data set which you've been working with a long time and just started applying machine learning. Well, in that case, you probably have some idea and so on. But when we're building the decision tree, we will not use this knowledge, our a priori knowledge of the data set. We will just let the algorithm run. So we will be using sklearn's description of the algorithm. So sklearn describes several algorithms for classification, and in particular we're going to use classification, right? We're predicting the number of cylinders. As a matter of fact, we can look at how many cylinders we have, how many different numbers we have, right? So you can see they go from 4 to 8, 4, 6, and 8. There's only 3 classes, actually 3 possible values, so we will be predicting these. Now this is a classification problem, of course, so we'll build the tree again following the description of the sklearn package. So we'll scroll down, and then you see there's a bunch of algorithms described, so we will be following generally this cart algorithm. I talked about it in my class. We looked at it in detail, and now we'll try to implement it in Python. Very simple, basic version of it, right? There are several other algorithms out there. So the feature of a cart algorithm is a basic cart algorithm is that it uses so-called binary trees. Now, when we say binary trees, it doesn't mean that the tree can be used only for binary classification problem, right? So the binary tree means the following. You know how the tree looks like a computer tree. So binary tree means that at every node there can only be 2 branches, left and right. You see, this pretty deep tree. And at every at every node, there is maximum 2 branches, and there are some nodes which we called leaf nodes, right? Like these ones which I'm pointing at. These nodes do not have branches at all. That's why they're called leaves. We stopped branching them at these points. So in a very simple version of the algorithm, we in cart algorithm, we will stop branching only when we reach when we reach pure state. So purity means, look at, there's three possible classes, right? In this case, this is iris dataset. And now again, it's three classes, but we're using binary tree, right? So it's important. But see, it stopped here. We will also stop at the point like this. Why? Because it's a pure state. So out of three classes, only one class has instances in them. The other classes are zero. So at this point, we will always be stopping if we reach this point. In this algorithm, let's see, in this version of a tree, also happens like it just happens so that it always stopped at the pure state, right? Again, this is a kind of a tree we will be building: left, right, and so on, leave node, etc. Right? So how do we make the split, right? The cart algorithm has a split according to this equation, which looks a little complicated. So I have a simplified version of it in the notebook, which comes with this video. So we will be calculating the cost of a split determined by this theta. So the theta is a parameter. And the parameter actually includes two things. It includes a feature and its threshold. So think of this. We have an empty cars, and we want to split this data set into two parts. Like in the very beginning, into two parts in such a way that maybe using MPG column, like any column, but it could be MPG displacement or whatever. So we will be using one of these columns, and we'll split it based on the threshold. So for instance, we will be splitting the data set into two parts, and the two parts will be, let's say, the threshold is 22. So for MPG lesser than 22, like Mazda RX, RX4 wagon, they will go into the left side of the tree. And whenever it's greater than 22, like 22.8, for instance, or 24.4, which is Mercedes 240D, these will be going to the right-hand side, right? So that's why we have left and we have right. And then for left and right-hand sides, we will be calculating impurity. So how do we calculate impurity? Well, it's a probability of each class. Right, so this is what's going to happen when we split the data set into left and right. On the left hand side, we will look at how many times there were 4 cylinders, 6 and 8, and we'll do the same on the right hand side, 4, 6 and 8, and then we will calculate the ratio of 4, 6 and 8 in each of them, on the left hand side and on the right hand side, and these ratios are called class probabilities. And using these class probabilities, we will be calculating impurity of the left hand side and right hand side of the of this node, right? So we made the split again. Look at this. We started with the node. It can be any of these nodes. And when we made the split, and when we made the split, like for instance here, it was left and right, and we calculate impurity on the left and on the right. And impurity is calculated using these like probabilities. So probabilities again out of off of the number of samples on the right and on the left. And then finally we combine these two impurities using the ratios of the total number of samples which went into the left hand side and the right hand side. So we have this weighted sum, and that is our cost. Now we want to minimize this cost by changing this parameters theta. And theta again is what? It's the column and the threshold. So effectively, we will run all the columns, MPG, displacement, horsepower, and so each one by one. And for each one of them, we will be finding the best threshold, and then we'll compare them across all the columns. And whatever column and its threshold delivers the lowest cost of this kind, that column and its thresholds will be chosen as the parameter for the split, right? So imagine when we got in the node, we made the split. And then we'll continue, and then we'll go to the right-hand side and split it further to the left and right, and then we'll take the left-hand side on the second level and then split it further and further. So we can do it recursively. But before figuring out how to do it, we will learn how to make one of the splits, and then we will build this recursive procedure. So this is sort of a bottom-up approach of programming. In programming, when we solve the problems, oftentimes we, this kind of a problem, we approach it either bottom-up or top-down. So top-down approach would be first I figure out how do I recurse, split things into small parts, and then figure out each part how to do. The bottom-up is first I learn how to make a basic split, like this split or any split, like any, you give me any node, I'll learn how to split it once. And once I know that, I can build it up into this recursive algorithm. So that's the approach we are going to use here, bottom-up. Okay.